Okay, maybe we can try something with recursion today. This is LeetCode 104, maximum depth of binary tree. And the question is asking, given the root of a binary tree, return its maximum depth. Maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So basically you want to find the longest path to a leaf node. So in this case, one of the longest paths would be from the root 3 to 20 and to 7 or to 15, which I guess would be depth 3. And that's what it says here. So I think we can solve this recursively, and we can think of a base case like just a single node with no children. The maximum depth of this node would be 1, so you would return 1 in that case. And for a node that does have children, you want to return 1 plus the maximum depth of your left and right children, or branches of the tree. So in this case, 3 would return 1 plus the maximum depth of its children would be the right child, which would have a depth of 2, because 20 has a depth of 1, plus the depth of 1 from 15, which would be 2. So 1 plus 1 plus 1 equals 3. So let's see if we can code this out. So our actual base case will be if there is no root, we would return 0. So if not root, we can return 0. Otherwise, if we are at a node that does exist, we want to return 1 plus the maximum of, I think, self.maxDepth of root.left and self.maxDepth of root.right. I wonder if this is the whole solution. Let me think about what this does. So if not root, that would be in the case where we have no root or we're at a leaf node, so we would return 0. Otherwise, we're going to return 1 plus the maximum of the depths of our left and right branches. So root.left would return 1 because 9 would return 1 plus 0. And root.right, oops, that was a typo. Root.right would return 1 plus 2, which would be 3. So let's see if this works. Cool, and then let's try submitting. Sweet, looks like it works. Pretty simple solution there, actually. It's like 3 lines of code, and let's try it with C++ now. So let's take a look at the definition of a binary tree node. It's a struct with a value and a left and right. These are tree node pointers. And then we have some constructors for creating objects, which don't look important here. All right, so I think that we can do basically the same exact thing. We will say if, I think we can do this in C++, we'll see. If not root, we can return 0. And otherwise we want to return the, oh, I actually don't know the math function for maximum in C++, so let's look that up. Okay, it's just called standard max. All right. So we'll say standard max of, I don't think you need to do self dot for C++ member functions. So we can just do max depth of root. And since this is a pointer, I think we need to do this for root.left and then also do max depth of root.right. And then I wanted to do 1 plus the maximum. So let's see if this works. Oh, maybe we need to move this inside of the parentheses. That works, and let's submit. Sweet, so that solution is also very simple, pretty much the same exact thing as the Python solution. So that was a quick one for today. Thanks for watching.